Okay, after a super hectic explanations on other previous two videos, let's talk about the shear stress. Alright, in a quick way, and hopefully we can clear the shear stress and the deflections. Alright, in this video, hopefully, I don't know. So the shear stress itself, alright, it comprises of Q. Alright, where the Q itself is your shear force. So what is the shear force then? Shear force, just take note that it's always your compressive force, alright, or the force that is being exerted, alright, the concentrated load, 1.5 kilonewton. I'll assume that you know what the hell is going on. If you don't know what the hell, you can just hit back to 11.2 onwards. These three videos I've gone through, so you can just watch it out. Then you can come back here. This is the part 4 already. So the Q is actually the concentrated force. Alright, the D is the one that we have derived when having a lot of problems with. The B itself is just a distance. Alright, the width of the thing. Alright, it's just the width of your sandwich. And the SE, take note, is this is the first moment of area. E is your Young modulus. Okay, where SE can be calculated using this equation. Okay, the Y itself, something that is a bit tricky, alright, because it is the shear stress at any location. Then any location actually comes from the Y, because it's where you pick where you want to look at. If you want to look at from this point, alright, then this is the Y. If you want to look at from this point, then this is the Y. So it depends on what you want to look at. So in the exams, you want to specify what type of if they didn't tell you where to look at, alright, shear stress of the core. If you shear stress of the core, then you look at this Y. Alright, if you shear stress of the face, then you look at this Y. Okay, if they never say anything, then you just do whatever you want. Happy can already, or you can do both of them if you're happy. Anyway, so if such a case that happens, this question may arise. Okay, is that the lecturer actually didn't use this one. He actually used this one only. So most probably he's calculating for the face, and therefore he's calculating for the face. So he's calculating from this distance, or he's calculating the shear stress of this face. Okay, so the shear stress of this face is just straight away using this thing will do. I don't know how it works. Alright, BTD, I think you know what the hell is going on. The BTD is just the one that we have derived quite easily just now in the first part of the video. Okay, and if you were to just calculate for it, let's see whether are we right. Alright, the face of the Young mass of the face is 210, alright, times 10 to the power of 3 megapascal. Okay, and then multiply by B is 50 mm. Alright, and then multiply by T, which is 0.5 mm. D is let me see, yeah, D is 18 mm, B is this one, T is this one. Okay, so let's come back. So D is 18 mm, and then the whole thing divided by 2. Alright, because it's divided by 2. So what do we have now? Yeah, give me a while. We have 47.25 megapascal. Okay, then 47.25, 10 to the power of 6. Alright, 10 to the power of 6 Newton millimeter. Okay, I am still confusing why they are taking megapascal in terms of millimeter. Mega Newton per meter square but if it's millimeter square, then something is gonna be different. Anyway, never mind, I'll leave you to think about it. I'll update also over here. But this is how he get the answer. Megapascal times mm, you'll get this thing, 47.25 times 10 to the power of 6 Newton millimeter. So this is the shear stress of the face. Alright, and I don't know why he didn't include the composite equation. Alright, maybe never mind. Give me a while. In case in the future that I update over here, then he says that you need to use the full equation. I don't know when do you need to use the full equation as well. If you use the composite, then do you use only the composite and then you cancel away the face? Or okay. So I think maybe you are using the face and the core together. So this is the overall shear stress. Alright, the overall shear stress. if you want to calculate for the overall shear stress of the material, including the face and the core, then you use this whole equation. If you are looking for the shear stress of the face, you use this equation. If you are looking for the shear stress of the core, you use this equation. Okay, so the core is the y distance. So the y distance is actually this one. Okay, and I think it all makes sense already. Alright, so this is the core, this is the face. So if you want to find the core, you just find for the core for itself. For the face, you find for the face. If it's everything, then you find everything. Okay, hopefully you're clear of it. So in this case, is the lecturer find for the face, and this is why we're calculating for the face only. Alright, and we have the values as shown over here. And I don't know whether this is exactly the value of his, but I don't know whether is it really right. So therefore, in case I may confuse you, so I'll just leave this video to end it as a shear stress type of video. So in the next video, I'll talk about deflection, which is also just look at the equation and apply. Alright, the only thing is only the D. Yeah. So the G also in the next video, which is also quite straightforward but the D is the main problem now. Alright, so next video, see you there. Bye bye.